Hello, everyone around the world, and welcome to another episode of the IEEE Power and Energy Society US and Canada Student Podcast. This is our monthly conversation with guests that inspire us, that speak from experience, and drive innovation. I'm your host, Clinton Gadet. I'm a third-year electrical engineering student at BCIT in Vancouver, Canada. And on the screen with us today are Paul and his brother Adamir is usually here. They are our producers, editors, and administrators extraordinaire. Not here today is our director of marketing and social media, Priya Mana. She might be dropping in a little bit later. And our mentors and executive producers, Hasala Dharmawardena and Conrad Schmidt, is that gray box that says IEEE PES membership. And they've been helping us along the way. As always, this podcast is made for you guys, everyone watching, students and young professionals in region 1 to 7. So please be brave, ask your questions in the chat, or ask to be unmuted, and you can speak directly with us and our guest. And our WebEx attendees are limited to region 1 to 7 PES members, but we are proudly live streaming on Facebook for anyone in the world to watch. So without further ado, it is an honor to introduce our guest this evening, Mazana Armstrong. Hi, Mazana.
Hi, everybody. Hello.
I'm going to read your bio and let everyone know what you're about. So Mazana Armstrong is the senior manager of the High Power Lab at Powertech Labs in Vancouver, Canada. The lab specializes in evaluation, verification, and certification testing of medium and high voltage equipment. So prior to her current role, Mazana was with BC Hydro Engineering, where her responsibilities included electrical aspects of high voltage transmission line design, operation, and maintenance. She has 25 years of professional experience, and her professional contributions include standards developed addressing electrical safety of the public, power utility workers, and facilities in close proximity of electrical power systems. Mazana holds a degree in electrical engineering from the University of Zagreb in Croatia, and a Master's of Science and PhD in Electrical Engineering from the University of British Columbia. She is a registered professional engineer and registered with the Engineers and Geoscientists of British Columbia, and a senior member of IEEE. Within the IEEE, Mazana has been volunteering with IEEE and PES for over 20 years and currently serves as IEEE Vice President for chapters. In this role, she is responsible for over 270 professional and 500 student PES chapters worldwide. She chaired the IEEE PES General Meeting in 2013 in Vancouver and was the chair of the IEEE Vancouver section in 2011. So Mazana is busy, and we really are appreciative of lending your time to us tonight. Welcome.
Thank you very much, Clint. Appreciate being here, and so happy to see, some of these new faces I haven't met before. Organizing this event, I just wanted to thank you all guys for doing this. This is really providing value to our members and really providing them with an opportunity to learn what IEEE Power and Energy Society stands for. So thank you so much for that.
Yeah, thank you. And please, again, I'm going to encourage people throughout this to participate and ask your questions. Don't be shy. We love it when people chime in. So just to give people a picture of what it's like to journey from beginning to where you are now, and the job you have now, and the role that you have now in IEEE and PES. How did you start out your career? Maybe academia. Like, why did you first go into electrical engineering studies in the first place?
Well, I was probably preconditioned to be an engineer. Both of my parents are engineers. They're mechanical engineers, and before I even made a decision to go into electrical engineering, my older sister was basically studying her electrical engineering degree, and this is all happening in Croatia. And I also went to a specialized technical high school that specialized in electrical engineering and power systems. So I was already in high school doing some labs involving machines and things like that, and circuit analysis and all of that.
Wow, is that common in Croatia? Is that kind of part of that, like, high school life?
I think less so these days. I think high schools are becoming more of kind of a general place to learn, like in North America. But at the time I was going to high school, you had specialized high schools, so that's kind of what I did. But honestly, after finishing my high school, I wanted to be a journalist.
Yeah.
So my parents slightly steered me towards engineering, right?
Right.
Which I appreciate, because I think I probably wouldn't be here today if I chose to be a journalist. I I think for journalists it's very difficult to move from one country to another, right? Because English is my second language.
Right.
And so I'm thankful and that I picked the electrical engineering in the end. There is another component to electrical engineering, is these power systems, right? And in my undergrad years, I did decide in my second year that I will be a power system engineer. And then I took those specialized courses. So I think very early on, I decided on this career in power systems.
Why did you specialize in power?
I think it's the machines. I really like generators, motors. It's to me, it's I need to see things spinning, if you will.
Yeah.
There was a choice to choose like communications or electronics or something like that. And in my second year, one of the professors asked me the questions like, "Why don't you just go to communications? Why power systems?" I was like, "I don't know. There's machines like when they they're just fascinating. That the whole process of generating electricity, transmitting it, distributing it, it's just so fascinating." And that was even before I really knew exactly everything that's involved in being a power engineer. I think I was just impressed by it.
I feel that. I totally feel that as like such a green engineer, like learning student training engineer myself. It's just still so mind-boggling to see these fields interacting and the work that comes out of it and the work that can go into it in the physics sense, like energy and work. It's incredible. And then the refinement of motors now and the way that they're orienting fields and optimizing things and generators, and it's just mind-boggling. It still seems like there's no end in sight of the innovation that's left for these kind of technologies.
Yeah. And this was so many years ago that we didn't even have these new things that are happening today, like smart grid automation. All of that is relatively new. So I would think that for you guys who are fairly young and starting out, the power and energy industry looks so much more exciting than when I was starting out.
Yeah. And how did the job transition from academia into the jobs go? Because I know so many people here watching today are probably right at that point, that are transitioning from academia to professionalism. So like, what is that experience like?
Well, believe it or not, I did it twice. When I got my bachelor's degree in Croatia, I actually did work for a few years, and then I went back to do my graduate studies, and so went back to academia, more school, and then I was looking for my first job again after finishing that. So maybe I will just focus on my first job, which was
Sure.
kind of first real job, I guess, which was for a distribution company. And I remember, I graduated and I was helping out with some research work at the university because I was struggling finding my first job. And there was this human resources lady that came from a utility to the university to talk about all the opportunities that they have at their company. And so after she was done with her lecture and kind of telling us about all the opportunities, and there was a lot of people in the room. So as she was leaving, I kind of jumped out on her and said, "Well, you know what? I applied for a few positions and I never heard anything back." And I was like, "What did it take to just get to the interview? I just wanted to talk to somebody and to, see if it would be a good fit." And all of that, and I told her a little bit about myself. And it turns out that was quite effective, because I was invited for an interview after that, and then got my first job with a distribution company, kind of more of like a distribution planning job. So yeah, so maybe something I would say to our students who are going to be transitioning, into their full-time professions is, I guess you have to know what you like and what you want to do, and just push for it, be assertive, tell people you really want that job. And I hire a lot of people. I've hired a lot of people in my career, and I see too many times people come in and they're like not even sure that that they even want to work, or they don't know enough about the position, or they seem a little bit shy and unsure, and that is too bad, because I think if you can make yourself into a confident person at an interview and just show that you're really excited to be a part of the team and to learn, that gives you so many points, like towards getting that position in the end.
Yeah. It seems like it's like a two-part problem getting that first job. Is like you gotta like find something that you truly are passionate about, so that you don't have to fake it when you're in the interview or regret it once you get the job. So like find something, really do yourself the favor of finding something that really drives you, gets you excited, and then if you do get into the interview, maybe convey that excitement or convey that passion, because no doubt there are some people who really do care, but maybe have trouble expressing it, or trouble like really getting it across that they are interested, or they didn't do necessarily their homework. So I mean, it's you gotta really want what you're in, I think. So that's really good advice, and you probably see that all the time.
Yes. Yeah.
What's some of the best the best hires that you've done, like that you've noticed, that were some of the experiences you had with your first impressions of people, and like that really ended up being a good hire down the line?
Believe it or not, I like kind of people to be very open and asking a lot of questions about the position. I always say interview is a two-way street, so it's not like we are only looking for a new hire. You are also looking for a company to work with, and it has to be a match.
Right.
So I would say that's probably something that I would encourage everybody to do, and show curiosity, like those questions. So what does your day look like, coming from you, and what kind of tasks you have for me, or what would I be doing? Put yourself in a position that you're already working there, and say, well, if I'm successful, what would I be doing? What would be the first thing I will have on my plate, and who is going to be providing me with like any help? How do I learn the best? Things like that. And there was like show that curiosity. And I think the best engineers I worked with are curious engineers. Yeah.
Well, I am curious, and I'm going to take your advice, and I'm going to ask you, what does a regular day look like for you, and what can you tell us about your role at Powertech Labs, and what is Powertech Labs?
Okay, yeah, that's a very good question. So, so Clint, you know very well, I'm not too far away geographically from you.
Yeah.
We're actually from the same area. I don't think we've ever met in person because of this COVID, but
you're the first guest we've had that's actually within driving distance of me. Yeah.
There you go.
Yeah.
So Powertech Labs is a subsidiary of BC Hydro. So BC Hydro is the largest utility in British Columbia. I'm not going to say the only utility, because there is FortisBC that also provides power to residents of British Columbia. And we are government owned. So Powertech Labs used to be a research and development branch of BC Hydro. And at some point, basically, BC Hydro, works for ratepayers, right, to provide electricity, affordable electricity. And we are more at Powertech. We are more of a working as if we were a private company, right? So the difference, I guess, that difference that we were out on the market, and we are out on the market providing services. That's not quite in line with what BC Hydro is doing for the province. So at some point, Powertech had to separate and be a separate business. So we are 100% owned by BC Hydro. However, we do have everything is separate. The financial system, everything is separate, and so I think that was probably the best description of Powertech. We provide these. We're called Powertech Labs, but I guess we provide a lot more than that. Just the laboratory services. There's the consulting services as well that we provide. And we actually do a lot of work for BC Hydro, even though you know they own us and somehow we are separate. We still do a lot of work for BC Hydro. Like the team that I work.
You have clients all over the world.
Absolutely, that is quite correct. In particular, my lab, it's called the High Power Lab. So we are just a one unit of a bigger organization that has about 230 people. My lab, the High Power Lab, there is more or less 8 to 10 people, depending on the current status, if we have any co-op students or interns and things like that. So we are a part of the bigger organization, and we do electrical testing for mainly manufacturers, and most of our clients are from the US. However, we have clients from Europe, from Australia, from Asia, and so larger Powertech, I guess, has some sectors, as we call them, and they're called transmission and distribution, substations, grid modernization. We have advanced transportation team that does hydrogen vehicles.
Wow.
We have electric vehicles group. We actually help BC Hydro put out those electric charging stations around the province. So Powertech had something to do with that as well. And then we have a generation team. So we have teams that deal with like some of the electrical testing for the generation side of our business.
Right.
They also do a lot of kind of investigations of when something goes wrong, there's a crack in the somewhere inside the let's say the on the equipment in the generation station. So they will be kind of investigating and proposing ways to fix it and things like that. The T&D side, obviously transmission and distribution, they cover some of the asset management issues that BC Hydro has, but they work for other utilities as well. We have lots of labs. There's electrical lab, there's mechanical labs. So I would say we are specialized, but we cover a wide range of problems that the power industry faces. So usually when there's an unusual problem, we also have a chemistry team. So if there is something that can be decided on based on testing some samples of, let's say, could be oil samples from transformers to decide what the health is or what the current state and condition of your equipment is. So wide range of services. And my high power lab, I would say it's probably the most exciting lab to work for, although maybe the second best lab at Powertech is the gas system. Those guys explode, like kind of pressurized, anything that's pressurized, they will test it to see if it withstands impact. of any kind, even like shooting guns at it, if it's going to survive. Or so I would say there's second best. But my lab will actually, create short circuits, and we're talking, up to 100 kiloamps. And some of those events are quite violent. My lab is closed right now, but if it wasn't, so if you were testing, you would, once in a while hear a big explosion and the whole building would shake. So
wow, so that's a common theme at Powertech is explosions of different types.
Yes.
Wow. I saw online. I looked at Powertech Labs, some of the most recent videos, and very recently, I guess during some of the pandemic downtime, a lot of upgrades happened to the lab and increased capacity. What was changed, and why did it need to be upgraded or changed?
Yes. So yeah, my lab is one of the oldest labs at Powertech. So that's kind of how everything began for Powertech. The oldest lab is the high voltage lab, and then after that, the high power lab. So our equipment is about 40 years old. So coming to an end of life.
Mm-hmm.
And so we are facing, the need to upgrade, because otherwise we're going to be seeing failures. We did have a failure last year in October, so exactly a year ago. One of our 230 kV transformers had an internal fault, and then basically it was done. It had to be completely rebuilt, and that rebuilding process took. We just energized it September, about a month ago, so it took about 11 months to get all the repairs done.
Right.
And,
is it because a transformer, like those things are so expensive and so specialized in the location that you have it in? It's probably so custom designed to fit the applications you're using it for, that it's not the type of transformer you would necessarily just replace. You had to repair it because it was boutique for you.
That is definitely one of the reasons. Yeah, so getting a new transformer in would have been a much bigger undertaking. It would take longer, for sure. And for us, there was a business impact. So it was very important to have it up and running as quickly as possible. And the best option was to, and I'm not going to even say repair it, but just completely rebuild it.
Wow.
There's only a few things that are old on that transformer. We did reuse the iron core, and then the windings was, everything was rebuilt. We put a new tap changer, new bushing. So now we're going into kind of technical terminology that not everybody may be familiar with. But transformer is a very piece of equipment.
Yeah.
Many many parts that you need to replace after a while. And in this case, it was a full rebuild, and we have a pretty much brand new transformer out of it.
Right.
And, yeah.
And how does the Powertex Lab approach to creating these currents? I remember in we had a previous briefing. You mentioned that that it's kind of unique in the way that you source your power and draw these high short currents.
Yes, we are connected to a BC Hydro system. So we are on the grid, we are on the network. Some of the other labs have their own generators. So they may be completely isolated from the network, or they may be connected maybe more on the distribution, at the distribution level. We are connected at the 230 kV level to BC Hydro's strongest point, strongest substation. Yeah, so we can draw power. However, we do also have limitations because we are grid connected. There's some limitations because we could, I guess, seriously impact the operation of BC Hydro system if we were drawing too much power. If you think of it, short circuit on a power system is a pretty significant disturbance, right?
Right.
So we are creating those short circuits multiple times a day.
Right.
So yeah, the impact could be significant. However, we are designed in a way, I guess, to minimize that impact. And we do talk to BC Hydro all the time as far as, hey, there's some testing coming up that we're gonna need that high MVA, high power level, and then they're aware of it. They may not approve it. Like, that's also part of our business, because we do depend on BC Hydro
Right.
to supply us. Yeah.
And by stress testing some of these very high power components, you're not just driving medium currents through these. You really are pushing things to some of the highest levels they would ever see on some of the highest transmission lines you'd ever see in Canada or North America. So lots of currents.
Yeah, that is correct. Yeah. So these usually we test to standards. So those standards are developed by IEEE. Actually, in this case, IEEE Power and Energy Society develops a lot of these standards that we test to. It could be IEC, which is more European based, but also international. There's a lot of standards out there. It could be country based, utility based, and really that's what's driving those levels, right? Following the standards, the manufacturers are trying to certify their equipment to certain levels so that they can offer it, I guess, to a wide range of utilities out there in the world. Yeah.
And that does serve as a pretty good advantage to have being grid tied with all that inertia. You have a more stable supply when you are doing those tests, so you can maybe have a little bit more control, more variables, I guess, versus someone who's locally generating their power. Just one generator doesn't have nearly as much inertia as a whole grid. So that would be an advantage. But what would be some of the disadvantages of or what would be some of the advantages of having if you were to have your own generator on site? What would be an advantage of that approach?
Well, first of all, we would be able to go to higher levels. So we have that limitation that we are grid connected, so we can only test to a certain level, and beyond that, we just have to turn down the clients and say, sorry, we can't do that testing. Right. I think if we did have a generator, we would basically be able to do more. However, our lab is so busy, we actually work 6 days a week.
Wow.
There's so much demand because these labs, high power labs, are very rare. There's not that many of them. We are the largest grid connected in North America. Sometimes these labs exist associated with manufacturers, so they only have them for their internal purposes, and they're usually not. They don't have the same capabilities that we do, right. So then they would still come to us. Yeah, I think that's why we are so busy. We are by far the busiest lab at Powertech, and we do all this work with not that many people, right? When you think of it, our core team is 9 people, right? So yeah.
So do you find yourself working 6 days a week, or is it more reasonable, like you kind of balance it with other managers, or are you really 6 days a week is real, a possibility?
Well, I work 5 days a week from Monday to Friday, and then we have we call it a Saturday shift. So we have an engineer and 2 techs that work from Tuesday to Saturday, and that's their normal days, right? They still get 2 days off, but so we overlap Tuesday to Friday, and then I don't see them on Mondays, and they don't see me on Saturdays. That's
more reasonable. That sounds good. We've got a message from Hasala, and he's asking, a name associated with Powertech is the late legendary Dr. Prabha Kundur. Do you know him? Did you know him? And did you have any mentors and sensei who helped you succeed as a power engineer?
100% that I knew him. Prabha was actually my supervisor for my PhD. And Prabha was the one that I worked for as an intern with Powertech. So my years with Powertech are actually a little bit longer than just the last 2 years. Since I joined from BC Hydro as a manager of the High Power Lab. But while I was still doing my PhD at UBC, University of British Columbia, I was actually spending some time at Powertech and helping Prabha with some of the research that were, or Dr. Kunder with some of the research he was doing and at the time. And he was such a fantastic person. He's actually one of the people definitely that I admired the most. I was extremely, obviously, shaken and sad when he passed away way too early. And Prabha was one of the people who tried to steer me towards academia, believe it or not. He actually felt that I should be a professor at the university, and he was always, I guess, putting my name out to different universities and saying, well, Mazana, there's these openings, maybe you should apply. And I, like, even from the moment when I was done with my PhD, I got my degree, I knew I was always going to work for industry, that I will not be a professor.
Yeah.
Yeah.
You want to put it to use. Well, not that professors don't put it to use, but you wanted to really get your hands dirty and see what you can make it happen.
Yeah, it's just an immediate impact. You go to work for utility, your decisions are, sometimes implemented on the same day, right? Because somebody maybe in the field is asking a question and you have to be prepared to give them the answer and instructions how to do things. And I'm not sure that you get that in academia, that kind of drive that things are kind of happening in front of your eyes, right? Like the system is being built in front of your eyes. So that was something that I personally enjoy. I obviously respect that many people actually do go into academia and do fantastic research work.
Yeah.
Perhaps some of those people are on this call, that they will be professors one day.
Absolutely, and none of us would be where we are without good professors. So it's all part of the gigantic, complicated puzzle. Yeah.
Yes.
You kind of made me wonder with some of those experiences where you are having to react in real time and sometimes under pressure. Maybe like a kind of a two-part question or a diopposing question. What has been one of the hardest, maybe failures is a hard word, but like one of the hardest difficult days you've had in this position that was just like, it wasn't a win, you definitely lost the battle, and what's been one of some of the like the most amazing kind of a really good accomplishment, because people really do appreciate hearing the failures too, I think,
Yeah, well, I don't believe in failures. I call them challenges. Because even if you don't succeed in what you attempted, I think you learn something. So and I shouldn't say I like failures, but I like challenges, because I feel then you have an opportunity to really prove yourself if you're challenged with something, right? So that's the way for you to grow. Probably one of my biggest career challenges were associated with my safety role at BC Hydro. So those are type of questions that, people's lives literally depend on your decisions, and you're on your toes, and they're very challenging situations, especially when you need so you're representing engineering, and on the other side you may have field workers. So sometimes those discussions are difficult because field workers have certain experiences that they rely on, and engineers usually crunch numbers, and explain things differently in that way. So I think that, you know, sometimes there is that kind of a communication or gap between engineering and between the field, and sometimes reconciling those differences in opinions.
Was it sometimes like changing like procedures of like maintenance procedures, or maybe was it like implementing new types of equipment that they had to adapt to, change their ways, and those kind of problems where it's just old habits?
Well, it's actually well, some of those discussions were related to how we are, you know, training our, let's say, our new employees at BC Hydro related to safety. You guys may or may not know this, but a lot of electrical, or most of the electrical incidents in at least on the transmission system, so that's what I was specializing on, are when the lines are de-energized. And the electrical hazard comes from induction. So the de-energized wires pick up voltages from a neighboring circuit, and if a person gets in contact with something that's you know, seems to be harmless, that's where those incidents happen. So sometimes I remember I was very passionate about maybe producing some training materials to explain these hazards a little bit better, and things like that. So I had I think it was a challenge, because I think the you know, sometimes just, you know, the way you're trying to explain the topic may not be the best way to present it to the actual people in the classroom. And I felt that was one of the challenges that I faced. And the other one was definitely on the design of transmission lines. So I was one of the people that would you know, be responsible for designing power lines as far as the clearances, like how big those towers need to be safe. And there was I remember there was a lot of kind of discussion back and forth on, and many different opinions. So I think when you work for utility, you have to be prepared for that there will be so many stakeholders, and you will have to defend your point of view.
Yeah.
Not just defend it with words, but with writing studies, writing reports, writing emails, whatever it takes to, you know.
I've noticed there are there definitely, like, I've been exposed to, there's a few different, like, not that I could categorize all engineers, but I've noticed there are some engineers that really take pride in being able to get as close to that threshold as possible, and it can be impressive when you can do something with the least amount of material for the lowest cost, and it's perfectly safe, and it really nails it. But on the other hand, some engineers really like to take into account the edge cases and know that, like, okay, it is a 100-year storm, you know, but we have to prepare for that 100-year storm, and then having to really overbuild things. And it must be interesting to be in a room with so many engineers that have different philosophies, and you have to reconcile that with a multi-million-dollar company.
That's exactly what it is, Clint. And a lot of the work that I did when I was at BC Hydro was related to that idea or notion of risk, right? Because nothing is 100% safe, and nothing is 100% unsafe. So it's always about how much risk can you accept and what is reasonable, right? Because otherwise you are overbuilding, and your projects will get, you know, too costly to even make them happen, right? So we actually, you do have to rely on your analysis and good engineering practices and standards to design things. That's why standards are so important. And it's so important to be involved in creating those standards, so that you can, you know, once you become an expert in your field, you can actually translate that experience into standards, so that other people can use it, right, and learn from them as well. So.
And you've developed standards.
Absolutely. I've definitely written quite a few of them for BC Hydro, so the internal standards. I've been a part of the CSA, so that's Canadian Standards Association, that creates standards for Canadian utilities. Not just utilities, but in general for our industry. But in particular, I was, working on some standards for our power industry, and then with the IEEE as well. Developing some, again, related to transmission lines and safety and reliability.
I got a nerdy question for you. What is your favorite standard that you've developed?
It has to be the one on pipelines, 100%.
Okay.
So that's not a well understood or well known topic out there, that and it's to do with induction and kind of that capacitive inductive coupling between high voltage power lines and other objects. And those objects can be pipelines, like gas pipelines, natural gas pipelines.
Does this arise when you have like long continuous conductive, like that's why it becomes a phenomenon, is that they're running parallel for long distances?
That's exactly. So you're doing well in your electromagnetics course. I can tell.
I'm trying. Right.
Yeah. So that's exactly what it is, Clint. And so my first introduction with that topic was BC Hydro, because we did have a lot of pipeline projects coming to BC Hydro infrastructure, and that's how I kind of got myself linked with the CSA, participated in the revision of their standard. But what bugged me is that IEEE had no standard to talk about it at all.
Wow.
Actually, yeah. So I was able to raise it in meetings with the IEEE working groups, and now we have a standard. It was issued, I think, probably now a couple of years ago, maybe a year and a half, 2 years ago. And I'm so proud that I had a big part of big role to play to actually make it happen, to create a brand new standard that never existed before, and it's helping our industry dealing with some of these issues that honestly they were like approaches were not consistent. People relied on, like, hey, if you're in the US, you may look at the Canadian standard, or you may look at the something that's happening in Europe. And there was not necessarily a lot of, I guess, consistency with the standards, because they were implementing some regional differences. And I think with the new IEEE standard, there's, all the good practices, I believe, went into that standard. So
what's kind of like the worst case scenario that can happen with with poor design with those two things in conjunction, the pipelines and power lines?
Well, I mean, it's the worst case scenario is pipeline explosion.
Really? It can build up pressure, or?
So what happened is, so this is kind of a conductive coupling, so electric power fault. So we all know, when insulation fails, that fault is going to, the fault current is going to flow into the ground, and it's going to try to find the path of least resistance, right, to the force. And one I think the thing that impressed me the most is, when you're doing your studies and calculations, ground is the little symbol for ground. Ground is so much more than that, right? Ground is solar resistivity, what you have in the vicinity, so if the pipeline happens to be in the vicinity, guess where that fault is going to go?
Right.
And arcing, the process of arcing to a metallic object can and will damage the object, right? And if the damage is severe enough, it can puncture the pipeline and ignite whatever is inside.
So, wow. That's interesting, because I can see how they would seem unrelated, but from my experience, I've been lucky to have a lot of different jobs in BC and the Northern Territories, and I've seen how the pipelines and the power lines, and probably in a lot of places, they coincide through the forest because of the cost it takes to clear cut those paths. It just makes sense. Like, we have to bring power to wherever this pipeline is going anyways, so they end up right alongside each other. And they might have seemed unrelated, but the way that they actually end up, it's kind of seems like there's probably a lot of those different standards that are just waiting to be created out there that we didn't quite see coming.
Absolutely. Yeah. Yeah, Clint. This is just, I guess, one of the problems that, we encountered when I was at BC Hydro. It's not the only one. A lot of them are related to the safety of the public as well. So it's not only about pipelines, but it could be just, as simple as you park your vehicle under a extra high voltage line, and then you touch your vehicle and you get hurt, right?
Right.
So the power lines are designed for that not to happen. You can still get a shock, but they're designed so you don't get harmed. But so a lot of people are not aware of that.
No.
It's really a big issue. And that was kind of an exciting part of my job at BC Hydro, because not only that I had to work on internal standards, and I also worked in external standards, I was also talking to the field, field workers, as well as the public, because the members of the public will notice this. They will say, hey, I was, I parked my car here, or my dog gets shocked,
Wow.
under the line, or, I'm noticing these things. So a part of my job was to go to talk to them, introduce myself as a specialist engineer from BC Hydro, and explaining exactly what is happening and why, it is not a safety concern in this case.
Mm-hmm.
But there's definitely cases where it can be a concern.
Mm-hmm. How do you in some of those meetings where you are debating different approaches, designs for standards, or different technologies, how do you make your voice heard in a place that can be dominated by an industry in North America, at least, where it's a lot of male engineers in a room, and seniors, like senior engineers and stuff? As you're coming up through your career, is there any strategy you could pass on to some of our viewers of, like, making themselves heard and asserting themselves? Like, what's some tools they can use?
Yeah, so that's a very good question, Clint. I think one thing that I've learned is to be very, assertive in stating my position and opinions, and to a point where you also have to be able to speak louder, right? And establish yourself as somebody who knows, right, the topic, and so you're establishing yourself as an expert. So I guess the trick is you come prepared to the meetings, and don't sit on the chair in the back and just listen, because this is not the way how you build yourself. You actually have to speak up. You have to ask questions. You have to challenge opinions that you disagree with.
Yeah.
Sometimes you have to compromise as well, and that's fine. But it doesn't take that long to be recognized as, hey, Clint knows something. Let me go see him when I have this technical problem, because in that meeting he spoke so confidently. He raised good questions. He had concerns. He was able to explain why a certain path is not good for safety or for our company. And yeah, so definitely participate in those meetings. Never be a observer.
Yeah.
Yeah.
Did the responsibility that you have now, did that happen. I think for some people it might happen suddenly. Someone gets a promotion, and all of a sudden you suddenly are looked to for the answers and relied upon. Whereas other people, it might happen gradually in a role in a company over 10 years or more or something. Like, can you think back on your career, and do you know if it happened suddenly or gradually or none of the above?
No, I think it happened gradually.
Yeah.
Which, I don't know, maybe for me it was the best case scenario. So what happened is when I joined BC Hydro, the person who I was replacing, who was retiring, was the only person in the department doing this job. So when I took over from him, you know, it didn't take too long to realize that the volume of work is just growing every day. And then also there was a need to upgrade all the tools we were using, and I'm talking about simulation tools, right? The calculation tools and all of that. So I was actually in a good opportunity to, hey, I need another engineer to hire, and another engineer, and another engineer. So in the end, the team of one grew up to be a team of 10, right? So I became, I guess, a team leader by just, business was expanding, and there was a need for me to start hiring. So I feel like I learned my people leadership skills in a very, I guess not in a very sudden way. I had time to, adjust by having 2 or 3 people on the team, and then bring in some contractors, so the team grew and got bigger and bigger. And I was able to, I guess, take quite a few courses on leadership, which are really helpful. And I think another one is through the IEEE and volunteering, which is what I've been doing for the past, I don't know, 22 years.
Yeah.
It's such a safe place for all of you out there to learn how to be a leader, because it doesn't really matter which position you're holding at the moment. You're always leading something. You're leading a task. You're leading this event, right? You're preparing for it. You're organizing it. You're finding speakers. You're getting the team together. So all of those are leadership skills that are going to, pay off 100% once you join the industry and you look for a new job. And I should also say, when you're writing that resume, don't forget to mention it. If you're an IEEE member, if you are a volunteer, all these things that are happening, that's things that you put in your resume, right? And this is just encouragement to whoever is on the call to start volunteering and to use this opportunity to learn.
Yeah. And whoever's on the call, if you guys have any more questions, we got about 10 minutes left, and don't be shy, chime in. And Conrad, I see you there.
Yeah. I just have one question, Mazana. Like you were speaking about like this volunteering. I'd like to see like if you can explain your perspective from a senior manager, how you bring the PS volunteering inside the company, and like how you encourage the people that's working with you to join the PS or like even volunteer, because we know it's hard like to deal with volunteering and job and grad school and all these parts.
Yes. So I was pulled into volunteering by a colleague from work. So that's how I started, and I am continuing that practice as well, encouraging pretty much everybody around me to join in. Like especially from my old team at BC Hydro, they're all volunteering. We have one of them is the representative for Region 7, which is Canada, for PES. We also have Felix, who is our, he's basically chairing this small committee on communications and website and, just maintaining the mailing lists of our members and things like that. So I think you kind of pull people in by leading by example, right? So they see you doing these cool things, going for, for example, when I go to a something like a JTCM, which is the Joint Technical Committee meeting, which is happening usually in January. When I go for that meeting, when I come back, I will always have a presentation, what I've learned. Not only that I want to do that, it's also a requirement by your company because they're sending you there, right?
Right.
And then that's what excites these young engineers. And of course, you pull them into standard development as well. Like that's a given. Here at Powertech, actually all of my engineers that work on my team, they're all IEEE members because they participate in creation of standards. They test to IEEE standards. So it's almost a business need to be one. Like you can't get away without, being a member. It's very beneficial for your career. That's where you kind of exchange, kind of learnings with people from industry, right? And come up with, I guess, better standards than what we currently have, right? So you're always improving. Every standard comes up for revision after a period of time.
Right.
You get involved, you pull in your younger colleagues. Powertech is really good on that front for sure, because we do fund people to participate. And then there is this other side of when you're volunteering. I'm on the governing board of Power and Energy Society, right? So some of all of the major decisions that are made for Power and Energy Society go through the governing board, right? So it's so exciting to be able to shape our society. And PES does so much, over 500 standards, right? That the Power and Energy Society issues. I don't even know how many working groups. We have all the committees that cover pretty much the extent of the field that we work in, right? So if you decide to be a power system engineer or to work in power and energy industry, I think it's a must to be really a member of the IEEE Power and Energy Society, right?
And looking at the way that things are going and the way that you see things changing and standards changing and the engineering evolving, if you were to be, say, in the shoes of some of the young engineers watching today, and you aren't allowed to say you do the same thing that you're doing now, what if you had to do something else different? Where would you lean towards specializing, and as far as where you see things that need to be done in the immediate future? If you could start all over again, what field would you get into?
Are you talking about like within power and energy, or?
Yeah, sure, within power and energy, but it can't be the exact same thing you're already doing. Just to do something slightly different.
Slightly different.
Yeah.
Definitely this side of like smart grid, renewable integration, and storage. I think that's really, really exciting. It's all something that we need. Automation, maybe part of the manufacturing, coming up with all these new smart equipment that we need, because our power systems are getting more loaded, and we're operating more at those critical limits, right? We don't have a lot of over-designed power systems anymore like we did in the past, right? So now you have to worry about avoiding outages. You have to worry about climate change, big storms. It's just like, you want to put as many sensors you on your system, and now you have big data. Now you have like tons of things coming back from your system. So how do you analyze it? How do you, learn about your system by collecting this data? How do you use it, right? All fantastic topics that are quite advanced, and so I would probably be like in that field, or maybe decide to do something like that. Those things didn't exist when I was when I was studying, right? So yeah.
And then we always like to ask one more aspirational question, or it's kind of a wish question. So if you could implement a change to the industry that you're in, and the specific things that you work with, and cost didn't matter, the technology, time development didn't matter. What's one solution you would love to see implemented if you could do it snap of the fingers? It could be regulatory, it could be technological, anything.
Well, I mean, I'm a very environmentally conscious person. Like, to me, we only have one Earth. You know, we live on it. We can either destroy it or we can preserve it. I think this is very relevant, especially to you guys who are younger, right? So leaving the planet in a better condition that we found it, it's extremely important to me. And this, you know, watching our carbon footprint, having more electric vehicles, and figuring out how we are going to, you know, accommodate that shift. So I would say if I could like do something like instantaneously, I would just kind of completely electrify, you know, all the vehicles, all the transportation out there, and just whatever solutions are needed to minimize our carbon footprint so we can have this Earth serving us for a lot longer. I think that would definitely be something. And then on a more of a sci-fi side, I would say teleportation, you know, warp speed.
Yes.
If we can,
yes.
like, you know, go, because on the other hand, not only that we have to preserve Earth, we have to find other places to live and explore and get resources from. So I think that's very exciting. So if we were able to, you know, travel far, which we can do right now, I think that would be
Oh, that's great. I appreciate that you did not limit yourself. You thought big. That's good. Yeah. Well, on that note, with all the aspiration and all the, I mean, it's really nice to see that someone nearby is working on big things that affect the rest of the world, and that someone with as much seniority as you also has some really refreshing perspectives on what needs to be done. And I think that there's going to be a lot of work for everyone watching in the future. There's a lot to be done, and hopefully we'll all collaborate. And just want to thank you for attending today, and thank everyone for attending. It's been really great conversation.
Thank you so much, Clint and the team, for the invitation. I really enjoyed it. Good questions, great questions. I had lots of fun.
Very good. If anyone wants to keep the conversation going or follow up, we have a little post on LinkedIn that can be that anyone can chime in on there and continue the conversation there. So yeah, the PES, IEEE PES LinkedIn, check it out. And
I'm gonna drop in the chat.
Thank you. Okay, the link's in the chat there. And everyone stay safe and have a great night.
Thanks, everybody.
Okay.
Thank you.
Good night, Mazana.